In the previous video, we created the individual components that are needed to create the automobile battery cable clamp assembly. Now, in this part of the tutorial, which is part 2, we are going to add constraints or relations and relationships between the parts to form the complete assembly. So this is the balloon and bill of material for the assembly. So create a new assembly file, and this takes us to the SolidWorks assembly workspace. Under the assemblies tab, we have a whole lot of commands that we can use to create the assembly. Since we have already opened all the parts here, we have this pop-up here with the parts inside that you can just click. When you move your cursor here, you can see this is the parts. So for every part, you check the orientation. If it is the right orientation, no need to touch it. If it is not, you can use these buttons here to rotate about any axis that you want. This is the right orientation, so just click to release. Now by default, when you insert the first component, it is fixed in the window. In order to make it float or make it free in the workspace, just right click and then float. Now you can click on it and then move it anywhere we want. But the best practice is to fix it in the origin of the assembly workspace. So that's what we are going to do. So come to mates and then drop down this arrow. We fix the origin of the assembly workspace, make it coincident with the origin of the clamp. We sure want to align axis as well. So okay, when you do this, the assembly will now be fully defined. Then we move on to the next part. So the second part we insert is the square bolts. So insert component, and after inserting the square bolts, again we insert the nut A. So you're going to insert the two at the same time. So click on the square bolt, hold the control key, click on the nut A, bring the square bolt here. You see, this is not the orientation of the square bolt. So the best axis to rotate about will be the y-axis. So click on this y-axis. Again, click on the y-axis, and this is the right orientation. So drop it here, click. Then for the hex or the nut A, rotate again about the y-axis and drop it here. Now let's add some relations. So for the relations, we are going to use the axis of the shafts and the holes. So come to this eye icon and then enable the temporary axis. So these are the axes for the shafts and the holes. So add mates. Click on this axis and then this axis here. Okay. And then coincide this face and this face. Now when you click on this square bolt and then rotate it, you can see there is 1 degree of freedom. So make parallel this face and this face. Okay. And then for the nut A, you want to add a screw motion to it so that it can move along the axis of the shaft of the square bolt. So we come down to mechanical mates, screw mates, use a distance per revolution, and then click on this axis of the nut first and then the axis of this shaft here, so that the rotation will be on the nut. Distance per revolution, we go with, let's say, 2. Okay. So now when you click on this, nut and rotate it like this, You can see the nut comes forward. So we want to set a limit distance in which the nut will move. So we go to the draft of the square bolt and then the clamp. The full length here is 70 millimeters. So go into the square bolt and then add the 70 to this 10 here. That will be 80 millimeters. So 80, we subtract the 80 from the 102. That'll be 22 millimeters. So that means the distance of the shaft here that is left outside is 22 millimeters. And that is this distance here, 22 millimeters. So we set the distance between this face and then this face. So come to advanced mate, limit distance, this face, and then this face. Now we have two distances. So the minimum distance 0 so that they can touch, and then the maximum distance 22 so that this face will be at the tip or the edge here. Okay. Now when you do that, the assembly now becomes fully defined. So now you can rotate the nut. Since it's moving in a slow manner, you can just come back to the mate here, right click on the screw and then edit feature, and then change the distance per revolution to, let's say, 5 millimeters so that the nut can move faster. So click on it again. And rotate it. You can see it doesn't move as it gets to this step. So bring it back again. And it also doesn't cross this face. So this is what we want. Now we add the fourth component, which will be the plate, and then the fifth, the hex screw, and then the last component, the nut B. Insert component, click on the plate, hold the control key, click on the hex screw and the nut B, and bring them here. This is the right orientation, so leave it here. Then for the hex screw, this is not the right, you have to turn it upside down. So the best axis is the x-axis. So rotate about the x-axis here. And then again, rotate this about the x-axis. So we have this. So mates, click on this and bring it up. Then we want to meet the axis of the hose. Click and move. You can move in this direction. So again, this and this. We have 1 degree of freedom here. So this face must sit on this face. Okay. Then remove this shafts inside this hole, and this face must sit on this face. Okay, we have 1 degree of freedom, so just align this face, make it parallel with this face. Okay, again, meet. For this nut B, we add a screw motion just like we added to this nut A. So mechanical meets screw motion, distance per revolution. First click the axis of the nut or the parts that will move, and then the axis of the stationary parts. Distance per revolution 5 millimeters will be cool. Okay, you cannot see the nuts, so I'll hide the components that are hiding the nuts. So this is the nut here. Bring it up. Now we're going to show the clamp again. So right click and show. Meets. So again, we go into the drafts of the clamp. The full length here is 20 millimeters, so take note of that. And then we go into the dimension of the plate. This is 5, so combining 20 and 5, that will be 25 millimeters. And finally, for the hex screw, adding 25 to this 10 will be 35. Now 55 minus 35 is 20 millimeters. So the distance of the shaft that is hanging outside is 20 millimeters. So limit distance under advanced meets between this face and then this face. The minimum distance we want to ensure is 0 so that they touch, and then the maximum distance is 20 millimeters, so they will be far apart. Okay. So that when the nut gets to this face, it stops, or it will no longer move forward. Then for the other side, instead of doing the same thing, which would be very tedious, we just pattern onto the other side, or better still, mirror onto the other side. So mirror component, mirror plane. You're going to use the base as reference or the clamp as reference, and we use the right plane, which should be the plane between the 2 points you want to mirror. Components to mirror, select the bolts or the screw, and then the nut. Next, and this is what you're going to have. Okay. So you move, since we mirrored, we move them at the same time. Now disable the temporary axis, and you can see fully defined assembly. So this is what we want. So yeah, that is the end of the second part of this tutorial, the final assembly. In the third part, which will come right after this, I'll show you how to create this exploded view of the automobile battery cable clamp assembly. So I'll see you in the next part. Safe.